Okay, so welcome back. We're going to do a couple examples of finding polynomials given certain conditions. We're going to talk about real zeros for this one. Okay, so what we're looking at is a situation where we're given a polynomial or some conditions, and we want to find a polynomial that satisfies those given conditions. So part A says what? Part A says we're given the zeros, -1, 2, and 4, and we're given that the value of the function is equal to 3 when x is equal to 1. So that we're going to use. Okay, so now, well, if we know it has a degree 3, right? So it has to have at most 3 distinct zeros. Well, here they are. 1, 2, and 3. So then we have 3 distinct zeros. So those are all the zeros. So we know, to start with, it has to have this form. Okay? So f of x must equal the factors x minus -1, or x plus 1, x minus 2, and x minus 4. Okay? And so that is immediately given to us because of the zeros. So they gave us the zeros, so we know that by the factor theorem, if these are zeros, then these must be the linear factors, right? Now, but there's one catch. We have an a out here because we can multiply these factors by any real number and that would be sufficient. Okay, but we want a specific value for a. Well, that's where this condition comes in. Okay, so how are we going to get the value of a? Well, what we're going to do is plug 1 in for all of these values. Okay? And we'll figure out what a is. So let's do that. Let's pretend that a wasn't there. Let's plug in f of 1. Okay? So let's do, let me get a different. Okay? So let's do f, excuse me, f of 1. Well, what happens here? We get 1 plus 1 is 2. We get 1 minus 2 is -1. We get 1 minus 4 is -3. And so what does that give us? That gives us a 6. Well, it's supposed to be equal to 3, and we get 6. So that means, what does the a value have to be here? Well, in order to make this equal to 3, what do we have to multiply this by? You got it, 1/2 So our a value then, that we're going to stick here in front, is 1/2. And so now we're finished. So this is the third degree polynomial. So this is, now we're not finished all the way, but here's what we're going to do. So that's our starting point, right? So we want to find a polynomial function. Okay, so now we've found our a value. We've got our factors. So now the next step is, now we're just going to expand it, simplify it, and write it in the correct form. Okay. So now that we got the 1/2, now all we have to do is expand this out. So we get this times this is going to give us x squared, let's see, minus x, because we get an x, minus 2x gives us a minus x, and then we get minus 2 times x minus 4 And now if we do it again, we use the distributive property again. Now I'm going to distribute the x across this. That's going to give us what? It's going to give us, okay, I'm going to carry the 1/2. So this is going to give us x cubed minus x squared minus 2x. Now I'm going to distribute the -4, and that's going to give us what? That's going to give us a -4x squared plus 4x plus 8. Okay. And now finally, we get 1/2 x cubed. Oh, hold on. One more thing. Combine like terms. We want to combine like terms first. So this is going to give us 1/2. This is going to give us x cubed. We've got a minus here and a -4 there, so that's going to give us minus 5x squared. Then we've got a minus 2x and a plus 4x, so it's going to give us plus 2x and plus 8. Okay, and so finally we get our final answers. Now I'm going to distribute the 1/2, and so our final answer for our polynomial function is going to be 1/2 x cubed minus 5/2 x squared plus x plus 4. And so that is our answer for that one. So f of x is equal to 1/2 x cubed minus 5/2 x squared plus x plus 4. And that's it for that one. Okay, now for this one, for B, we're going to do this basically the same thing, except this time they're giving us 1 0, but it has a multiplicity of 3. So this is a repeated 0 or repeated root. Okay? So that means we have 3 factors that have the same 0. So that means when we write this, f of x is going to equal x plus 2 cubed. And again, we're going to have an a value out here, right? We're going to have an a value that we have to figure out. Okay? The a might be 1. We don't know until we plug it in. But we know that f of -1 equals 4. So let's see what we end up with. So if we put in -1 plus 2, right, cubed, so -1, oops, hold on a second, oh, that's 2. 2, so -1 plus 2, which is going to give us a 1, right, so this is going to be 1 cubed, which is 1. Well, it's supposed to be equal to 4, so that means our a has to be what? Has to be 4. So this a value is 4. So now we can expand this out and simplify. Okay, so let's do the FOIL method once, right? So it's going to be 4 times x plus 2 times x plus 2 times x plus 2, right? And so this is going to give us what? That's going to give us x squared plus 4x plus 4 times x plus 2, right? And now what we're going to do is we're going to expand it out again. So now we're just going to distribute the x. And so if I distribute the x, I get 4 times, I get x cubed plus 4x squared plus 4x. And then I distribute the 2 to all these. I get plus 2x squared plus 8x plus 8. And so now I'm going to simplify this. And I'm going to get x cubed I get x cubed plus, well, I've got 4x squared and 2x squared, so this is going to give me a 6x squared. And then I have 4x and an 8x, which is going to give me 12x. And then I've got the 8. And so now if I multiply through, my final answer I get f of x is equal to 4x cubed plus 24x squared plus 24x, oh, hold on, 48x, sorry. 48x plus 32. And so this becomes my answer. And that's how you do it. Again, make sure you're able to do these on your own. Practice these. Go back and set these up and do them yourself. See if you can walk through them without looking at the solution. Until then, have a great day. That's it.